Welcome student. Today we are talking about our first alkaloid, that is morphine. And as you know that morphine was isolated in 1806 from opium, and it is the first alkaloid isolated from a plant. Opium contains 10 to 23% morphine along with around 20 other alkaloid. Morphine, codeine and thebaine are the three structurally related opium alkaloids having phenanthrene carbon skeleton and are known as morphine or phenanthrene alkaloids. So today we are going to talk about morphine, which is a very powerful painkiller, but it is also a very addictive drug. And you can see we have different compound. This is the bottle of codeine tablets, and this is of heroin. These are the derivatives of uh, this morphine alkaloid. Morphine alkaloid have a bitter history, and when we start a new topic we need to go through the historical background, which gives us little bit idea about its experimental research. Sartner was the first person who successfully isolated and extract morphine crystals from the terry poppy seed juice after a series of experiments on rat and stray dogs. He reported his discovery of a slip including molecule in letter to the editor of the Tremensdorf journal, the Pharmacia, in 1805, and again the following year. After qualifying as an apothecary assistant, Sartner moved to Enbeck in 1806, where he was employed as an assistant in the magistrate's pharmacy. Following Napoleon Bonaparte's invasion into Europe, French legislation prevailed, permitting Sartner to open a shop in Westphalia. Morphine was isolated, as already I have discussed, from the raw opium in 1805 by this German pharmacologist Friedrich Wilhelm Edmund Sartner. Morphine is a potent suppressor of pain, and it is very useful drug in pain full condition, especially when you have a severe chest pain during the heart attack. To produce instant sleep within no time, this drug is mostly useful. Isolation of morphine in its pure form was a result of the years of research done by Sartner during 1803 to 1817. Well, as I've said, the history of morphine alkaloid is little bit bitter, because in 18 years after morphine's discovery, it was used for homicides. A 20-year-old French doctor, Adam Casting, mixed morphine in wine to give to his friend Auguste Bellet to kill him. And he hasn't used it once, but he used it for 2 times. Date of the murder is this too. He was arrested June 2, 1823, and the victim is Bellet, as already mentioned here. Two wealthy lawyer brothers has been killed by giving them this morphine in the wine. Higher doses of morphine brings a person to a death. It is happened in France. So very bitter history morphine alkaloid has. Now, how this term morphine come into existence? Morphine sense the gift of Morphos. The name morphine comes from a Greek word, a god of dreams, Morphos. Morphos is a god of dream, and from Morphos it is converted into morphine, and the word is coined by Shortener. to designate the main alkaloid in the opium as this morphos. From morphos it is converted into morphine, and the meaning of morphos in Greek is god of dreams. So when you take morphine, you feel that you are the god of dreams. Morphos was the son of Hypnos, and the Greek word Hypnos means god of sleep. So when you take morphine, within no time you would be in sleep and you feel that you are the god of dream. And from that hypnosis word is derived. Hypnos was also the brother of Thanatos. Thanatos means the god of death, and that is why the higher doses of opium leads to permanent sleep, that is death. That means you will reach in the uh, to the brother of Thanatos, that means a god of death. Morphine not only brings sleep dreams but may cause death when taken into large doses. So this is the bitter history of morphine. Another bitter incident with morphine was Austrian neurologist, founder of psychoanalysis, and was a psychologist, medical doctor, Sigmund Freud, the father of psychoanalysis. By summer of 1939, Freud was frail of suffering intense pain from terminal inoperable mouth cancer. On September 21, 1939, Freud grasped the hand of his friend and Dr. Max K and reminded him of his earlier pledge not to terminate torment me unnecessarily. Now it is nothing but torture and makes no sense. After receiving this permission of Freud's daughter, Anna Skor injected the first of three heavy morphine doses. Freud slipped into coma and then never awoke. So this is another bitter history associated with morphine. In September 1939, Freud, who was suffering from mouth cancer and in severe pain, persuaded his doctor and friend Max K to help him commit suicide. And later on 21 and 22 September, this is September month going on, friends, administered large doses of morphine that result in Freud's death on 23rd September 1939. This is also a case of morphine poisoning. Definition, so many definitions are there for morphine. Morphine is a natural opium alkaloid. It is a dried extract obtained from the capsules of poppy plant known as Papaver somniferum. It requires approximately 10 gram of raw opium to produce 1 kg of morphine. Another definition leads us to from a drug used to treat moderate to severe pain. It binds to opioid receptor in the central nervous system and some other tissues. Morphine sulfate, the derivative of morphine, is made from opium. It is a type of opiate and a type of analgesic agent. Another definition is a drug made from opium used to stop people from feeling pain or to make people feel calmer. This is very few definition I have included. You can go through some on net and can find more definition about it, but we can define as a natural opium alkaloid, and it is directly extracted from the capsule of poppy seed plant known as Papaver somniferum. So that would be the definition of alkaloid, morphine alkaloid. Classification according to the ring structure: it has phenanthrene ring skeleton, and it has three different derivatives which contain phenanthrene derivatives: morphine, thebaine and codeine, and another two are papaverine and noscapine. Benzoisoquinoline derivative they are. This is the benzoisoquinoline nuclear structure in it, and this has a phenanthrene derivative. So this consider as morphine and morphine derivative. According to the synthesis, morphine and codeine come into one class, that is natural opium alkaloid. Heroin, pholcodine, they are semi-synthetic opium alkaloid, because when alkaloid is acetylated, it is converted into heroin. And we have synthetic opioid, that is pethidine and methadone. These are thadine and methadone. These are the two synthetic opioids are there as well. We need to study morphine. And friends, this is a hot topic today, as so many drug related cases are going on in recent days. Pharmacological action: analgesia. Morphine cause analgesia. Morphine relieves severe deep seated pain like visceral 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 pain and pain of trauma. We have pharmacological action as well. Morphine produces euphoria in presence of pain, but in the absence of pain, it produces dysphoria and restlessness. With an increased dose, it produces sleep. Tolerance is noted to both euphoria, that is mu receptor, and dysphoria, that is kappa receptor. Sedation is there as well, because it bring deep sleep. Morphine induce sedation in analgesic dose and is useful when pain is accompanied by insomnia. On the other hand, morphine derivative, morphine sulfate, an opioid agonist, is relatively selective from the mu receptor at site in the preaqueductal and periventricular gray matter. Morphine can be administered orally, intravenously, rectally, subcutaneously, through spinal injection, as well as through inhalation. The principal therapeutic action of morphine is analgesia. Morphine is indicated for the relief of severe acute and severe chronic pain. Other therapeutic effect of morphine includes anxiolysis, euphoria, and feeling of relaxation. Morphine remains the drug of choice in acute myocardial infarction, as it relieves pain and result in significant peripheral dilatation and reduction in systematic vascular resistance. Drug is also dramatically effective in cardiogenic pulmo, pulmonary edema, as it calms the patient and reduce the dys, dyspnea and myocardial oxygen demand. Another pharmacological action is anti-tussive property. Anti-tussive property is constitute a heterogeneous class of compound that inhibit cough through either a central or a peripheral mechanism, or mixture of the two prototype and common drugs. Morphine has anti-tussive property, depress the modular cough center, and effect not blocked by naloxone. It is not used clinically, and related drugs like codeine with less receptor depressant and additive liability are used. These are narcotic drugs that you need to keep into mind. Nausea and vomiting, these are the side effect. Common features with analgesic doses, and includes by stimulation of the chemoreceptor, trigger zone CTZ, tolerance developed to vomiting on prolonged use. Higher dose of morphine inhibit the vomiting center as well. So this is the pharmacological action of morphine. Now let's go through what actually morphine is. Attempts to define the term alkaloid originated at the time of the discovery of this compound. Sartner, an apothecary's assistant from Westphalia, first isolated morphine, as we already discussed earlier. Contemporary scheme of morphine, Frederick Sartner, who first isolated this alkaloid in an impure form in 1805 and did know that it was converted from the pathway of tyrosine, one of the amino acid. The correct morphine structure was determined by Gulland and Robinson in 1923. Moreover, 200 years after Suttner's isolation, scientists are still discussing the synthesis of this alkaloid from a molecular point of view, or for natural or total synthesis. This is a good example of scientific evolution of knowledge of alkaloid. Morphine and its cogners, codeine and thebaine and oripavine, these are the compound we're going to see in the figure 1, as well as other minor constituents of the opium poppy latex continue to garner interest of the chemist community for a number of reasons. The focus of the total synthesis of this alkaloid in academic sector has not waned and now span almost 60 years since the seminal disclosure of the first synthesis, total synthesis given by Gate after using the retrosynthetic analysis followed by the forward synthesis in 1952. These are the different derivatives of morphine and cogners. Morphine, thebaine, when you see the structural difference between morphine and thebaine, you can see that morphine contain hydroxyl group both the side and codeine contain methyl group over here. So this can be converted into two structure. When you are using hydrogen, it is morphine. When you are using methyl group over here, O methoxy group over here, it is codeine. Thebaine is a dimethoxy group. Two methoxy group will convert it into thebaine, and instead this if you are taking hydrogen, that is oripavine structure would be there. Morphine, codeine and thebaine, the difference in the structural arrangement is only this hydrogen which is substituted by methyl group, and both the methyl group is there for both this hydrogen, then it is converted into thebaine. Heroin is the acetylated form of morphine. Heroin is used as a drug. When morphine is acetylated, both the hydrogen substituted by acetyl group and both acetyl derivatives considered as heroin. These are another derivatives, different derivatives of this morphine. Raw opium contain approximately 25 different alkaloids by weight. Depending on the variety, the chief alkaloid are morphine, that is available in the alkaloid raw opium between 4 to 21%, codeine 0.8 to 2.5%, thebaine 0.5 to 2%, papaverine 0.5 to 2.5%, nascopine 4 to 8%, meconic acid that available in opium, raw opium 3 to 5%. So many alkaloids we can extract out from opium poppy seed. The poppy botanical family Papaveracea. The poppy botanical family Papaveracea contains tyrosine, the amino acid derived alkaloids such as morphine, codeine, thebaine, papaverine, narcotine, narcine, isoboldine, and salsolinol. These are certain compound can be obtained from the poppy botanical family, that is Papaveracea. These are the things which is quite important as far as MCQ point of view. The poppy family is relatively large, comprising 26 genera and about 250 species. The family is distributed in subtropical and temperature regions of the northern hemisphere. The opium poppy, that is Papaver somniferum L, is a known source of opium from its latex. The poppy family alkaloid have strong biological and medicinal impact, and they are also strong narcotics. And you know that how much current topic the narcotics is, and therefore so many scientists have taken interest in synthesizing the or giving the total synthesis of morphine and its derivative. We have this list from 1952 to 2005. This many person has taken interest in giving the different synthetic route to get different derivative of the alkaloid. This is the reference for that. Structural elucidation of morphine. The presence of hydrophenanthrene ring system was suggested in 1881 by isolation of phenanthrene as a product of zinc dust distillation of morphine, which is one of the degrading process as we have gone through earlier. The location of the 3-oxygen functional group was established by degradation, leading to phenanthrene derivative oxygenated at 3, 4 and 5 position. We can see in the figure here. Morphine is there. Morphine 2-hydroxyl group is there. So it is completely a morphine structure. When it is treated with dimethyl sulfate in presence of sodium hydroxide, one of the hydrogen is substituted by methyl group, and we are going to get the codeine, one of the derivative of morphine, which is further methylated by methyl iodide, and then in presence of base, when we heat, we're going to get the Hoffman degradation, and the ring will open from this side, and we're going to get the ring opening reaction over here. Treating with sodium hydroxide, the shift of double bond is converted from here to here. The shift of double bond will going to gives us codimethine. So this is a codimethine compound which is further methylated by methyl iodide, and in presence of base hydrolysis followed by it will going to gives us a tertiary salt, quaternary salt of iodine. Quaternary salt of iodine treated with C2H4 will going to get, because of the beta hydrogen present on beta carbon, the substitution of trimethyl will going to gives us more methyl morphol, which is further treated with pyridine HCl. On heating we're going to get this derivative, hydroxy derivative, and then it is converted into this compound 4.69, which is the degradation of morphine, and we can see that on third, fourth and fifth position there is a hydroxyl group. So that can be established as we have seen stated over here. The location of oxygen function was established by the degradation. We're going to get in the phenanthrene derivative that at position 3, 4 and 5 there should be a hydroxyl group, and that we can prove over here by this degradation of morphine. Exhaustive methylation process of morphine, or Hoffman degradation of morphine, whatever you want to say for this degradation you can. Morphine on heating with hydrochloric acid gave apomorphine. The morphine apomorphine rearrangement was clarified by Small. So this is morphine to apomorphine rearrangement is there. So morphine treated with HCl converted into apomorphine. Now what is the difference between morphine and apomorphine? So we can see the phenanthrene structure will going to establish over here, and the nitrogen methyl group is there, hydroxyl group is over here, ethyl linkage get open over here, and we're going to get the 3D ring structure over here. Phenanthrene ring structure is over here, but ethyl linkage is removed. We're going to get the apomorphine rearrangement reaction. So this is nothing else, a rearrangement. It can be envisioned as an attack by a proton on the ethereal oxygen, followed by the opening of oxide breeze to give carbonium ion, which further undergoes detachment of the ethanamine breeze at carbon 13 and dehydration, leading to aromatization. The reattachment of the ethylamine carbonium ion at carbon 6 gives apomorphine, which already we have seen in the above case. And apomorphine is an interest because it established a relationship between the morphine alkaloid and the benzyl isoquinoline alkaloids as well. So this is the molecular structure. Now followed by that we need to discuss the biosynthesis of morphine and codeine. For that we'll have this tyrosine, the amino acid. Tyrosine is converted into dopamine, where this aldehyde or phenolic derivative is treated, and the cyclization, this aldehyde group is going to attach over here. Cyclization take place and we're going to get reticuline, uh, reticuline converted into this form, where you can see that the secondary amine now converted into tertiary amine, and that undergo the cyclization process. We'll get one more cycle over here, which is converted into salutaridine, where the hydroxyl group is converted into carbonyl compound. Hydroxyl group is converted into carbonyl compound, which further converted into thebaine. Thebaine is converted into neopenone. This is a ketonic group, and methoxy group is there, which is converted into codenone. Codenone have the similar kind of structure, which is converted into codeine, and codeine converted into morphine. So this is the route by which morphine is going to be obtained biologically. This is the biosynthesis of morphine. And the stepwise biosynthesis of morphine is shown over here. Tyrosine converted into dopamine, which react with this aldehyde derivative, and then the cyclization take place over here. So primary amine now converted into secondary amine, which now further treated methylation reaction is taken place, and that methylation convert this hydroxyl group into methoxy group, and one methyl group attached over here. Substituting hydrogen, we're going to get reticuline. Reticuline undergo cyclization, so the cyclic structure is going to be established over here. So we will going to get a one cyclic structure over here, and two methoxy group, another hydroxyl group get methylated, and one hydroxyl group gets substituted over here. So we're going to that sinister reticuline converted into rectus reticuline. It is isomeric form, and then we're going to get the phenolic coupling over here. So both the phenolic hydroxyl group converted into carbonyl group, which converted into salutaridine, where methoxy group remain over here, and we're going to get one hydroxyl group converted into carbonyl group. Okay, and that gives salutaridinol alcoholic group is established in place of carbonyl group, and through SN2 reaction we are going to get this thebaine structure, where two methoxy group would be there. When it's treated with non-reagent, we're going to substitute this methoxy group into carbonyl group, that is neopenone, and that further going to gives us codenone, and codenone have this methoxy group over here, which is converted into hydroxyl group, and we're going to get the morphine biologically. Another is the gate synthesis. In gate synthesis, we have a target molecule, that is morphine, and from morphine we are going to apply retrosynthetic analysis. You need to understand retrosynthetic analysis, where we need to have a target molecule first, and by performing certain chemical reaction philosophy, will going to cleave the compound, or we can break the molecule into simpler form, and with this simpler compound we'll start the synthesis. So that is called retrosynthetic analysis. We have a target molecule. Now this is inclined arrow. On inclined arrow, what is given, that is the oxidation. So the oxidation of morphine leads us to this compound, And then when we will going to think a forward reaction, this is a backward reaction from target to starting material. When we perform a forward reaction, when we reach to this derivative, we're going to perform the reduction, we're going to get the morphine. So whatever we are going to perform in the forward reaction, that is written below the incline arrow, and what we are converting the target molecule, that we will going to show into both side of the incline arrow. We're going to get this derivative. On epimerization, we're going to get this derivative, which further on further reduction will gives this phenanthrene derivative, and reductive amidation will gives this phenanthrene structure derivative, and then 4 plus 2 cleavage will going to gives us here 4 and 2 cleavage here, from here and from here. When we cleave this structure, we're going to get this butadiene and this structure. So first we need to synthesize this one from a simple compound, and then when we are going to add this butadiene to this, we're going to get the morphine. So after this retrosynthetic analysis, we come to know that we need to have this kind of fragment and butadiene to start the synthesis or total synthesis of morphine. Total synthesis given by Gate. So it is a Gate synthesis of morphine. Gate achieved total synthesis of morphine in 1952. We're going to see the figure after this slide. Diels are the addition of butadiene to 4-cyanomethyl 5,6-dimethoxy 1,2-naphthaquinone. That is structure number 4.70 yielded. Gives the adduct. On addition reaction will gives us adduct, that is 4.71. On catalytic hydrogenation, the adduct 4.71 underwent the ring closer to ketolactam, that is 4.72 molecule. The Wolff-Kishner reduction of carbonyl group of 4.72 compound, followed by the reduction of amide carbonyl by the treatment with lithium aluminum hydride, and N-methylation by treatment with formaldehyde formic acid, yielded product 4.73, which was resolved. The double bond of 4.73 was hydrated to give compound 4.74, and the methyl ether group was selectively demethylated, and product 4.75 was oxidized to ketone and brominated to yield the product 4.76, which produce a beta unsaturated ketone, that is 4.77. Inversion occurs at the adjacent center of carbon 4 to produce the natural orientation. The reductive removal of one bromo atom gave codeine convertible into morphine by the cleavage of ether group by treatment of pyridine hydrochloride. Starting compound 4.70 was obtained from 2,6-dihydronaphthalene 4.72 as shown in the figure. So when we see the figure, we come to know about this total synthesis, that this total synthesis bifurcated into two parts. First part will be the synthesis of 4.70, the starting compound, which we have seen in this previous slide. After the retrosynthetic analysis, this is the starting molecule. To get this starting molecule, what we need to do, we need to start with 2,4-dihydronaphthalene, and then treating that, we're going to get 4.70, that is the starting compound, and taking that starting compound, we can reach to synthesis of morphine. So that is part 2. So we'll see these two part of Gate synthesis. This is part 2. So I will reach to part 1 first, so that you can understand how this compound is going to be obtained. This is the starting material after the retrosynthetic analysis we need to obtain, that is 4.70 molecule. To get that molecule, we need to use this compound, which is 2,6-dihydronaphthalene, which is treated with acid chloride in presence of pyridine. We will going to get this ester, which is treated with sodium nitrate in presence of this acetic acid will going to get this cyanide group attached over here in this position. Reduction by H2PD and carbon will going to get the cyanide group converted into primary amine, which is further treated with FeCl3. Both the hydroxyl group and amine group is converted into carbonyl group, so dione is going to be obtained. That dione is treated with sulfur dioxide in ethanol, will going to get the hydroxyl group over here, so we're going to get the hydroxyl group. Ester linkage is still over there. On further treating with dimethyl sulfate and potassium carbonate, we're going to get this hydroxyl group methylated, so 2-methoxy group is going to be obtained, which on doing base hydrolysis followed by the treatment with HCl, we're going to get this ethyl linkage removed and hydroxyl group is going to be obtained over here. For again the same treatment is going to be given as we have treated with sodium nitrate, so diazotization process would be there, then followed by reduction with H2PDNC and treated with ferric chloride. Again we're going to get a dione as we got over here by this 3-step. That's 3-step include in the one reaction, we're going to get dione. That dione is treated with one ester compound with cyanoester compound in presence of triethyl azide. We're going to get this linkage over this position for the cyclization, which is further treated with K3FeCN6. Substitution of hydroxyl group will going to gives us this ester group over here, and the cyano group over here. Dione hydroxyl group is now converted into dione again, so we will block this, protect this group, then treated with potassium hydroxide in presence of methanol, that is a base hydrolysis followed by treatment with HCl. we are going to get the starting material, that is 4.70. So after getting that 4.70, that is for cyanomethyl 5,6-dimethoxy 1,2-naphthoquinone obtained from part 1, treated with butadiene, that is the addition reaction taken place, we are going to get this adduct, which further treated with H2 in presence of copper chromate at 27 atmospheric pressure. This is a catalytic hydrogenation, will going to gives us this cyclization taken place over here, and we'll get the secondary amine. Underwent ring closer to ketolactam 4.72 is going to be obtained. This is a ketolactam obtained. That ketolactam where we will perform Wolff-Kishner reduction of the carbonyl compound, and that Wolff-Kishner reaction followed by the reduction of amide carbonyl by the treatment with lithium aluminum hydride and N-methylation by treatment with formaldehyde formic acid yielded 4.73, which was resolved, and it is hydrolyzed, which gives us 4.75. That structure is methyl treated with methyl ether group, was selectively demethylated in presence of potassium hydroxide and dione ethyl dihydroxyethane. We're going to get this 4.75. On oxidation, oxidized ketone and brominated it, so we're going to get the oxidation, hydrogen is removed, and we're going to get the ketone. And on doing bromination, dehydrobromination would be there, we're going to get 2 bromine attached here and here, and it is treated with the base followed by the bromination. The dihydrobromination with a base is taken place, will going to gives us this compound. Again the bromination is performed, we're going to get a bromine over here, which gives us an beta unsaturated ketone. This beta unsaturated ketone undergo reduction in with lithium aluminum hydride, will gives us codeine, and codeine by reductive removal of one bromine atom gave codeine converted into morphine by the cleavage of ether group by treatment of pyridine hydrochloride. So with the pyridine hydrochloride we are going to get the morphine. This is a total synthesis. First we need to from this 2,4 2,6 dihydronaphthalene. We need to get this substituted oquinone. That oquinone, sorry, that we will use into this part 2 synthesis, and in part 2 it is added with butadiene, and by performing this many reaction we're going to get the morphine. This is a total synthesis of gate, and that gate synthesis can be represented in a short way like this. This is a short way to represent the forward synthesis of morphine given by gate. This is the primary part 1, and scheme 1 will going to gives us a starting material, and that starting material we can use to get the morphine. Thank you very much for paying attention to this lecture, and please mark activity in Moodle at it is considered